Here's another video of the Gauss-Jordan row reduction modified method. This time I've decided to make it so that we do have to do a little bit more in our row operations before we can actually get that 0 in the non-pivot number location. Step number 1 is the same, and that is to make sure that your equation is transferred from a system of equations into a matrix. And so again, you have that equation number 1 and equation number 2, which will transfer into row 1 and row 2 of your matrix using the coefficients of the x, the y, and the totals. Make sure if your equations are not in order, in other words, one equation might be the x's and the y's and the totals, but the next equation they might have the y's, then the x's, and then the totals. Make sure that you are placing the coefficients all in the same location in your matrix. So you want the x's, the y's, and the totals regardless to be the same in your rows, regardless of how they're presented in the equations up above. Row number 1 would then have an x coefficient of a 3. The y coefficient is a -2, so make sure that you are pulling that negative, and your total is a +6. Your second row would be the second equation coefficient, so starting with x, we have a 2, the y's we have a -3, and on the total we have a -6. Put those start and stop lines to begin and end your matrix, and you're ready to begin. We do not have any fractions or decimals in this problem, so we're going to move right on to finding our first pivot and trying to clear the column. The 3 is going to be your first pivot number. It is the first number in the first row that's not a 0 as you go left to right. So we're going to actually take that first row because it is our pivot row, and we're going to transfer that into the next matrix as is. So 3, -2, and 6 will transfer over, leaving a little bit of space in between the matrices to write the row operations. So now we need to think of the column that our pivot number is in and focus just on those values. So we have a 3 and a 2. If I were to add or subtract those values right now, I will not get a 0, which means I'm going to have to multiply one or both of them by something in order to get me a pair of numbers that when added or subtracted would give a 0. So I'm kind of looking for a common multiple. So with 3 and 2, I could turn both of those into the number 6 using multiplication. If I take 2 times 3 and 3 times 2, that would give me a 6, and then I could subtract them to get a 0. So instead of thinking of it as 3 times what I want, I'm going to again reference this 3 as my row 1 number. So if I take 2 times my row 1 number, I'm going to record that here in the middle, 2 times my row 1 number, that would give me a 6. If I take 3 times this row 2 number, so 3R2, that's going to give me a 6. If they're both 6's, what I need to do is then subtract to get a 0. And that becomes then my row operation. 2 times the row 1 number minus 3 times the row 2 number, and I'm going to put those answers in that open second row, the non-pivot number row. So you're going to now go one column at a time, column 1, column 2, column 3, and perform this row operation. You can use your calculator and just type it in as you have it written. So as you get to a row location, pull that number and put it into your calculation or into your calculator, or you can do it all in your head. So we're going to take 2 times the row 1 number, so that's going to give us 6, minus 3 times the row 2 number, which is another 6. So subtracting, I get a 0. So the second column, I'm going to take 2, so column 2, what you might want to type into your calculator or keep track of it in your head, is you're going to take 2 times the row 1 number, which is the -2. And then you're going to subtract 3 times the row 2 number. The row 2 number is a -3. And that total is what you're then going to place into your matrix. And you should get a 5. You'll go to column number 3, and do the same thing. So I'm going to take 2 times the number that's in the row 1 position, which is the 6, minus 3 times the number that's in the row 2 position, which is a -6. So that'll be 12, that'll be 18, that'll give you 30. Record that answer in the column 3 position. If I go on and look, the only number in that first column that is not a 0 is the pivot number. So we have successfully cleared the column. So now we move into our second cycle, which is now in your second matrix. Move to the second row, move to the first number left to right that is not a 0. So that would be the 5. This is now going to be your pivot number. The 5 is in that second row, which means that second row is going to remain unchanged. So 0, 5, and 30 are going to transfer over as row number 2 values. You're going to use that second column as your strategy column. That's your pivot column. So you're going to use the 5 and the -2 and try to think of what pair of numbers could I create using multiplication so that when I add or subtract them, I get a 0. And when I see a 2 and a 5, I'm instantly thinking 10. So if I take 5 times the -2 and 2 times 5, I can get a -10 and a +10. And if I add them, I can get a 0. So I'm going to write that in the middle. So I'm going to take 5 times the row 1 number that's in the pivot column. That right now is going to give me -10. So I'm just trying to keep track of those totals. And then I would need to create a 10 down here, take 2 times that value. So I'm going to take 2 times the row 2 number. Double check whether you should be adding or subtracting, so pay attention to your signs. So I've got 5 times the top number, which keeps it a -10. 2 times the bottom number is going to keep it a +10. Opposites have to be added in order for them to be a 0. So I'm going to be performing addition. So again, now I'm going to back up and go column 1, column 2, column 3, performing this set of rules. So column number 1, I'm going to take 5 times the number that's in the row 1 position, which is the 3. And we're going to add to that 2 times the number in the row 2 position of column 1. The row 2 position of column 1 is a 0. And that math gives us then a 15. So 15 is going to be my first answer in that first row, first column. Moving on to column number 2, I'm going to take 5 times the row 1 number, which is -2, and add to it 2 times the row 2 number, which is the 5. And this is the one that we designed to be equal to 0, and it does in fact equal 0. So my column 2 number is a 0. And column 3, 5 times the row 1 number, so we're going to take 5 times 6. And we add to it 2 times the row 2 number. The row 2 number is 30. So this is going to be 30 and 60, so we're at a total of 90. This work that I'm putting down here is not part of your actual problem, so it does not have to be shown, and it should not be moved up into your workspace. This is the only thing that counts as an answer, is having your matrix, having your row operation with an arrow leading to where new answers are going to be found, having that next matrix, having another row operation with an arrow showing you again where new answers are going to be located in that top row. So we don't need to have all of this kind of messing up our work. I'm just showing it to you because it's easier if I show it, then maybe it'll help you remember how to do these types of problems in the future. We do not have a third row to move to, so we don't have a pivot number, a new pivot number to find, so we are finished with the cycling piece of this. And now what we have to do is go back and locate where our pivot numbers used to be. So in the top row, it was the upper left-hand corner. In the bottom row, it was in the middle. We want to, using multiplication, turn each of these numbers into a 1 at a time. And this is a 1 row at a time modification that we're doing. Any number times its reciprocal will turn into a 1. So if I have a 15 here in the first row, if I take 1 over 15 times that row 1 number, it should turn into a 1. But what I do to one number in that row, I'm going to have to do to the whole thing. So I'm going to take 1 over 15 times 15, which is 1. 1 over 15 times 0, which is 0. And 1 over 15 times 90, which is 6. The second row has a pivot number of a 5, so we're going to take 1/5 times that number, which is a row 2 number, to create a 1. So again, just taking that number and flipping it over. Every number times 1/5, so 0 times 1/5 is 0, 5 times 1/5 is 1, 30 times 1/5 would be 6. And so we get, again, the x's, then the y's, and our totals. Our top row should tell us then what x is equal to, and our second row should tell us what y is equal to. And we can write that as an ordered pair because it is a point of intersection on a graph, and then our problem is complete.